Today's lesson is on systems of linear equations. After today, you'll be able to understand that solutions to a system of two linear equations in two variables correspond to points of intersection of their graphs, because points of intersection satisfy both equations simultaneously. You will be able to solve systems of two linear equations in two variables algebraically and estimate solutions by graphing the equations. You'll also be able to solve real-world and mathematical problems leading to two linear equations in two variables. First, we're going to look at our vocabulary. A system of linear equations is a set of two or more linear equations in the same variables. A solution of a system of linear equations in two variables is an ordered pair that makes each equation true. First, we're going to look at our example for solving a system of linear equations using a table. We want to solve the system y equals x minus 5 and y equals negative 3x plus 7. For our first step, we're going to make a table of values. So for our table, we're going to plug in our two equations. We have y equals x minus 5 and y equals negative 3x plus 7. We're then going to solve each of these equations if x equals 0, 1, 2, and 3. If we plug 0 into our first equation, we have 0 minus 5, which is negative 5. When we plug 1 in, 1 minus 5 is negative 4. If we plug in 2, 2 minus 5 is negative 3. And if we plug in 3, 3 minus 5 is negative 2. So we've just filled out our first row here. Now for our second equation, y equals negative 3x plus 7, if we plug in 0, we're going to have negative 3 times 0, which is 0, plus 7 would be 7. Now if we plug in 1, negative 3 times 1 is negative 3, plus 7 is 4. Now we'll plug in 2, and negative 3 times 2 is negative 6, and negative 6 plus 7 is 1. And for our last point, we're going to plug in 3. Negative 3 times 3 is negative 9, plus 7 is negative 2. Now when we look at our table, we want to find the x value that gives the same y value for both equations. That would be the x value of 3, because for both equations we get negative 2. So our solution to this system is 3, negative 2. Now we're going to look at our second example. We're solving a system of linear equations using a graph. We want to solve the system y equals 2x plus 3 and y equals negative x plus 6. The first step is to graph the equations. Once we've graphed our equations, we will find the point of intersection. So we'll graph both equations. You can see that this equation here was y equals 2x plus 3, and this line represents the equation y equals negative x plus 6. We want to see where they meet, and they meet at 1, 5, so our solution is 1, 5. We can plug this solution into each of our equations to see if it is true. So we can plug in 1, and we'll have 2 times 1, and which would be 2, plus 3 is 5, and we would get 5 for y. We can also then plug in 1 in our second equation for x. So we're going to get negative times the 1, so which is negative 1, plus 6 is also 5. So this works for both of our equations. Now we have an additional example that goes with 1 and 2. We want to solve the system of linear equations using a table and using a graph. You may pause the video and try it on your own, or you can follow along. The first thing we're going to do is we're going to fill out our table. For our table, we have the equations y equals x minus 1 and y equals negative x plus 3. We're going to plug in 0, 1, 2, and 3 to both of these equations. If we plug in 0 for the first equation, we have 0 minus 1, which is negative 1. Now we're going to plug in 1. 1 minus 1 is 0. Next thing we'll do is plug 2. So we have 2 minus 1, and that is 1. And then we will do 3. 3 minus 1 is 2. We're going to do the same thing for our second equation. We'll first plug in 0. So negative times 0 would just be 0. Plus 3 is 3. Now we're going to plug in 1. So negative times 1 would be negative 1. Plus 3 is 2. Now we're going to plug in 2. Negative times the 2 would be negative 2. Plus 3 is 1. And then we're going to plug in 3. Negative times our 3 would be negative 3. Plus 3 is 0. You can see from our table that our solution is going to be 2, 1. We get the same value for y when we put 2 in for x for both of our equations. We're now going to graph these two equations to see if we get the same thing. So now if we want to graph the first one, y equals x minus 1, we can graph this using slope intercept form. We could plot our points. So we'll go ahead and try slope intercept form. So our y-intercept is negative 1. So we're going to put our point at negative 1. And then our slope is 1. It's positive 1, so if we go up 1, then we need to go to the right 1. Same thing, if we start at our original point and go down 1, we go to the left 1, so that it remains positive. So our line for this equation would look like this. Now we're going to graph our second equation. Our y-intercept is 3. And our slope is negative 1. So if I go up 1, then I have to go to the left 1 so that I make sure it's negative. Same thing if I go down 1, then I go to the right 1 so it remains negative. Then I can draw my line, and now I need to look and see where these two lines meet. They meet right here, and that point is 2, 1. This is the same solution that we got in our table. So our solution is 2, 1. Now we're looking at another key idea. We're going to solve a system of linear equations algebraically. For our first step, we solve both equations for one of the variables. The next step is to set the expressions equal to each other and solve for the variable. The third step is to substitute back into one of the original equations and solve for the other variable. So for our third example, we're solving a system of linear equations algebraically. A middle school yearbook committee has 35 members. There are 7 more girls than boys. Use the models to write a system of linear equations. Then solve the system to find the number of boys x and the number of girls y. So for our two equations, we have number of boys, which is x, plus number of girls, which is y, equals 35, or x plus y equals 35. And this equation is written right here. For our second one, we have the number of girls y would equal the number of boys x plus 7, or y equals x plus 7. And that is this equation here. So we have our two equations. So our first step is to solve one of the equations for y. The second equation is already solved for y, so we can just go ahead and solve the first one. So we're going to solve x plus y equals 35. And we're going to solve that for y. When we solve that for y, we're going to be subtracting x from both sides. So we get y equals 35 minus x. We could also write this as y equals negative x plus 35. For our second step, we set the expressions equal to each other and solve for x. So if we know that y is equal to x plus 7 and y is also equal to 35 minus x, that tells us that x plus 7 would be equal to 35 minus x. So 35 minus x equals x plus 7. Now I'm going to solve this equation, and the first thing I can do is I can add x to both sides. That will get rid of it on the left-hand side, and that moves it to the right-hand side. If I do that, I have 35 equals 2x plus 7. Then I can subtract 7 from the right-hand side and subtract 7 from the left-hand side, and 35 minus 7 is 28. So they have 28 equals 2x. Now I can divide by 2, and I'll get that x equals 14. For our third step, we substitute x equals 14 into one of the original equations and solve for y. So we're going to start with the equation y equals x plus 7. If I know that x is 14, I substitute that in for x, so I have 14 plus 7, and 14 plus 7 is 21. So I know that y equals 21. So there are 14 boys and 21 girls on the yearbook committee. Now we have another example. You can either pause the video and try it on your own, or you may follow along. Solve the system of linear equations algebraically. This is our second example. We have our two equations, x plus y equals 20 and y equals 2x minus 1. The first thing we're going to do is we're going to solve the first equation for y. When we solve the first equation for y, we're going to be subtracting x from both sides. When we do this, we get y equals negative x plus 20. We also could have put that y equals 20 minus x. That's the same thing. Next, we're going to set the expressions equal to each other and solve for x. If we know that y equals 2x minus 1, and we also know that y equals negative x plus 20, that tells us that 2x minus 1 would be equal to negative x plus 20. Or we can say negative x plus 20 equals 2x minus 1. Now we're going to solve this for x. So we can start out by adding x to both sides. So we're going to add x to the left, which gets rid of it, and add x to the right. So 2x plus x is 3x. So now we have 20 equals 3x minus 1. Our next step then can be to add 1 to both sides. So then we're going to have 20 plus 1 would be 21, and that would be equal to 3x. And then we can divide both sides by 3, so we get 7 equals x, or x equals 7. Now we're going to substitute x equals 7 into one of the original equations. One of our original equations was y equals 2x minus 1. We're going to take that 7 and substitute that in for x. So we're going to have y equals 2 times 7 minus 1. 2 times 7 is 14. So we have y equals 14 minus 1. And 14 minus 1 is 13. So we know that x equals 7 and y equals 13. So our solution is 7, 13. Don't forget to fill out your notes and remember to watch the video again if needed.